Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today we have got a solid available with us, and this is the isometric projections of the solid which is available with us. And in the isometric projection, the front face, the top face and the side face, so all these three faces, they are available in a single 3D view. So here we are required to draw the orthographic projections, that is front view, top view and the left side views of this solid over there. And in order to start with the construction of the orthographic projections, we need to work out the dimensions of the front view, top view and the side view of this particular solid. Now from the front view, as we can observe, we are going to see the width of the solid, which is equal to 100 millimeter, and in the front view, besides the width, the height of the solid, that is 65 millimeter height, will be available. So the front view dimensions, they happen to be 100 millimeter by 65 millimeter, whereas in the top view we are again going to see the width of the solid, which is equal to 100 millimeter, and besides the width we'll also be getting the depth of the solid equal to 50 millimeter. So the top view dimensions, they will be 100 millimeter by 50 millimeter, while in the side view, as we look at this solid, so we are going to get the dimensions of the depth of the solid, it is equal to 50 millimeter, and in the side view, besides the depth, we'll also be able to see the height of the solid equal to 65 millimeter. So the side view dimensions, they are 50 millimeter by 65 millimeter. Now let us work out the different faces which we will be able to see in the front view, in the top view and in the side view, right? So here we have different faces of the solid which will be visible to us from the front, top and the side view. So in the front view, we are going to see only one face. So please check, this is going to be the single face which will be available with us in the front view, right? So when we look at the solid from the front side, the surface which has been named A over here, so this surface A will be visible to us in the front view, right? So this is the surface A, and you can also note that the front view, top view and side view, the color coding has also been changed regarding the different faces which will be available with us. So in the front view, we are going to witness face A, whereas in the top view, we are going to witness 5 faces over there. The face 1, it will be this rectangle which we'll be able to see. This is surface 1, and the true shape of this surface will be visible in the top view. Similarly, this is the surface 2, which is corresponding to the top surface of the web over here. Again, the true shape of this surface will be available to us in the top view. Similarly, you have this surface 3 corresponding to this well. So this surface 3 will again be visible to us in the top view as a true shape. And you have surface 4, that is the top surface of the second web. Again, this will be viewed in the top view as a true shape. And finally, it is the surface 5. This is your rectangular surface which will be corresponding to the top surface of the lower block. So if we consider this to be a lower block, so the top surface will be your surface number 5, right? So corresponding to this section. So again, true shape will be available in this, in the top view over here. Then you have the side view. So here please check, we have to draw the left side view, but we can't observe the surfaces over there. So there will be one surface Y, which will be a rectangular surface which will be available on the other side. So this surface Y and this surface Y, so they will be similar to each other, right? So this is one surface we'll be able to observe from the left hand side. So this is surface Y which we are going to observe from the other end. Similarly, you have the surface X. So this is your surface X. So this surface X, it will be viewed from the other end over there. Since we are required to draw the left side view, and even in the left side view, the true shapes of the x and y surfaces, they will be available. So in this orthographic projections, we are going to witness true shapes of all the surfaces, that is A, 1, 2, 3, 4, 5, then X and then Y surface over there. So all these 8 surfaces, they will be available as true shapes in the front, top and the side views over there. Now let us start with the construction of the orthographic projections. So to begin with, we are required to draw the XY line, right? So this is our baseline. Then you, for the corresponding to the intersection of the profile plane with the horizontal plane and the vertical plane, we have got this vertical reference line which is called X1 Y1 reference line. Now let us start with construction of the front view over here, right? So here we start with the construction of the front view. So what in the front view, what we are going to witness? We are going to witness the width of the solid and the height of the solid. So the width of the solid is given to us as 100 millimeter and the height of the solid is available with us as 65 millimeter. So now we have drawn the front view over here. Top view we will be drawing below the XY line, and left side view will be drawn onto the right hand side. Okay, so let us start with the front view. So front view width, we have 100 millimeter. This is the width of the solid. Then we have got the height of the solid, which will be equal to 65 millimeter. Okay, so now we have drawn the height of the solid equal to 65 millimeter, and then corresponding to 65 millimeter, once again the locus line or a projection line will be drawn, which will be extending to the left side view, because in the side view also the height will be visible over there, right? Now let us draw the top view. In order to draw the top view, we know the depth. So in the top view, we are going to witness the width of the solid. So we are not going to label width of the solid again, because it has already been dimensioned over here, right? So no dimension should be repeated onto any given technical drawing or the engineering drawing. So you have the width of the solid equal to 100 and the depth of the solid, this is equal to 50 millimeter. Now we have to transfer the side view in such a way that the dimensions corresponding to the front view and your top view, they will be transferred to the left hand side view. So for that, we draw this transfer line which is at an angle of 45 degree, and then we draw the horizontal projections from all the, you see, horizontal lines which are appearing in the top view, and similarly corresponding to the front view also. So all the horizontal lines, they will be extended onto the left side view, and then in order to transfer this depth over here into the left side view, now these horizontal lines through this transfer line, they will transfer vertically upwards over there into the left side view. Now the boundary of the left side view has been defined. So this boundary is equal to that, you can check, this is the width of the solid which is equal to 50 millimeter. So this is the width, and this is the height of the solid which is equal to 65 millimeter. So only in the starting stages we have mentioned the depth and the height, but later on we are going to remove these dimensions, because the depth of the solid has already been, you see, dimensioned over here, and the height of the solid, it has already been dimensioned over here, right? So later on we are going to remove these two dimensions which we have shown over here. Now let us start with the construction of the surface A, because this is the one surface which will be visible to us as a true shape in the front view. And which is the surface? Please see, I am going to mark the surface over here. So here into the surface A, I can break the surface into three parts. That is, there is a lower block, you can check. This is a lower block which I will be able to see in the surface A, and then you have web number 1 which is drawn over here, and then leaving a gap for a well, you have web number 2 over here. Okay, so this way, if I divide the surface A into three portions, I will be able to draw the surface in the front view over there. Now we can see that the thickness of this lower block, it is happening to be 15 millimeter. So I am going to draw a construction line at a height of 15 millimeter from the bottom of the solid, right? So I get the locus line for this lower block over there. So this is my lower block of the solid. So corresponding to the lower block, I have got the height equal to 15 millimeter. So I have marked this height over here and drawn a construction line. Then I want to draw web number 1. That is my part number 2, element number 2 corresponding to surface number A. Now, where is it located? It is located at a distance of 30 millimeter from the right hand corner of the solid. So from the right hand corner of the solid, it is located at a distance of 30 millimeter, and the width of the web happens to be 10 millimeter. So what I have done, from the right hand side corner, I have marked a distance of 30 millimeter, and then the web thickness I have marked as 10 millimeter. And where this web is going to start? This web is going to start from the top, and it is going to end at the top surface of this lower block, right? So it is going to end at the top surface of the lower block. And now I have drawn two construction lines. So these are two projection lines which I have drawn in the front view, and I have also extended them onto the top view. Why I have extended them onto the top view? Because these projections, they will be visible to me even in the top view. So the projection of the top surface of web number 1, it will be visible even in the top view, right? So I have drawn web number 1. Then I need to draw web number 2. So web number 2 is also symmetrically located, that is 30 millimeter from the left hand corner, and the width of this web is also equal to 10 millimeter. So now from the left hand corner, what I have done, I have marked the location of the starting of the web at a distance of 30 millimeter, and then I have marked the thickness of the web is equal to how much? 10 millimeter. Now the second web will be drawn. So this is the construction of the second web. And again, another thing needs to be noticed, that this web thickness has been extended onto the top view also. The reason is because this top surface of the second web will also be viewed in the top view of this orthographic construction. Now I have drawn the construction of the surface A. Now I need to make sure that there is continuity which is existing in the surface A. That is, no straight line will be drawn over here and no straight line will be drawn over here. So I have got the background for the surface A. Let me complete surface A. So please check, this is my bottom block. I am joining this with blue color. Then I will be joining the webs over there, and there is first web. So there is an integral web joined with the lower block, right? So these webs and the lower block, they are not separate. It is a single solid and the continuity is maintained over here. Then I join the second web. So this completes the front view construction of the solid. And which face of the solid I have been able to obtain over here? In the orthographic front view, I am able to obtain surface A, right, which corresponds to the front view of the solid. So this is the front view of the solid. So in the front view, this surface A will be visible to me over there, right? So let me mark the surface A over here. So this is the construction of surface A as viewed from the front view. And another thing must be noted, since the surface is parallel to the vertical plane, so the true length of this surface A has been obtained onto the vertical plane, right? So I have been able to obtain the true shape of the surface onto the vertical plane. Now let me draw the top view, because you can check all the surfaces of the top view, they are automatically drawn while I was constructing the front view of this particular construction over here. Now I can just join the points over here so that all the 5 surfaces, now you can check, there are 5 surfaces which are viewed in the top view, and all these 5 surfaces, they will be viewed as true shapes in the top view, since all these 5 surfaces, they happen to be parallel to the horizontal plane. So let me start with the construction of the top view. So the boundary of the solid is visible, please check. the boundary of the solid is visible, so I have darkened the boundary of the solid over here. Then this is the first rectangular surface, then you have the web number 1, then you have the well, then you have second web top surface, and then you have the fifth surface over here, which is again the top surface of the bottom block. So surface number 1, 3 and 5, they represent the top surface of the bottom block of this particular construction. So once I join these two webs, please see, I am getting surface 1 over here. This is surface 2, which is corresponding to the top face of the second web. Then you have the well surface. Then this is your element number 1 or your first web, and this is your surface 5 over here. So these are 5 surfaces which are viewed as true shapes in the top view. Reason? Because all these 5 surfaces, they are parallel to the horizontal plane. Now let me work out the side view of the solid, right? So usually we will be given that you draw the right hand side view, because these two surfaces, they are readily seen. But here as a special case, we have been asked to draw the left side view. So in the left side view, again these two surfaces which are appearing on the other side, they will be worked upon. So since we cannot mark those surfaces because they are not visible to us in the isometric projections that we have got, so I have marked these surfaces as surface X and surface Y. And mind you, these are not these two surfaces, surface X and Y. These are the corresponding surfaces on the other side. So on this side, please check, on this side, this wall of this web will be my surface X, right? And then this wall which is going down on the other side, it will be my surface Y. But for the ease of visualization, I have marked these surfaces as surface X and Y over here, because these two surfaces, surface X on the other side and surface Y on the other side, they are just similar to these two surfaces. So since I have completed this construction, so I can join this rectangle over here, because this outer boundary will be visible to me from the other side. I am looking from this side. So since I am going to draw the left side view, it has been drawn onto the right hand side, and this line I need to darken. So this line will be corresponding to this segment. This is the edge corresponding to the top surface of the lower block, right? So this is the edge corresponding to the top surface. So better visualization will be possible through this. So this sort of rectangle, it is available while you are going to view the solid from this end over here. So once we draw this edge over here corresponding to the top surface of this particular low block, then you can divide this total, you see, side view into two parts. First part is surface X, which is lying onto the other side. This surface is not this surface. This surface is lying onto the other side behind this wall over here. And this is my surface Y. So this completes the construction of the orthographic projections of a solid, so whose pictorial diagram we were provided with, right? So once we complete this construction, so in order to have better clarity, now we can remove these shapes over here, right? So please check, I have removed all the faces from the orthographic construction. Similarly, I have also removed the depth and height from the side view, because depth was marked over here, height was already marked over here. And then I have also removed the faces from the original solid, so that we can have a better correlation between the solid isometric projection and the orthographic projections of this particular solid, right? So I hope that through this discussion you would have understood properly that how should we go about construction of the orthographic projections when the isometric projection they are available with us. So we have drawn the front view, top view and the left hand side view of this particular solid. So we'll be continuing with further discussion on few more cases of the development of the orthographic projections in the coming lectures. So this is all for today. Thank you very much. Thanks a lot.